Hello everyone, welcome to AWS and Linux Foundation course. Today we are going to discuss about the Linux operating system basics, right? The agenda for today is to talk about the Linux operating system architecture, the Linux directory and the file hierarchy, and we'll talk about some common basic Linux commands that we need to use on our day to day as part of our job responsibilities, right? Well, without further delay, let's get into the discussion. And first, I'm navigating to the AWS management console. Why do so? Right? We have seen a discussion that first we need a infrastructure. On top of the infrastructure, that we need a operating system, right? And of course, if you need to use the Linux operating system to customize this as per your need, first we need to have a infrastructure. Help me guys. Who is providing the infrastructure? The infrastructure is now I'm taking the AWS cloud, right? So hence the reason, first let me navigate to the AWS management console to create a simple EC2 server that will be giving us the Linux operating system. Then we'll see how to use the Linux operating system in order to configure that to run our businesses, right? Well, so you may be seeing that we are jumping on to the Linux operating system basics today. Is mean that the AWS EC2 is completed, right? So it's like the hand to hand. So this is not like a academic sessions like a one the I meant to say from the academic terminology perspective, right? Once the chapter is completed, we will move on to the one more chapter, and I'm sure there will be no difference from one, no similarities from one chapter to another chapter and the dependencies as well, right? But when it comes to the real-time IT, we are all using all these technologies together to solve a single problem. It means that we cannot deliver something like we completely done with EC2 then move on to the other one. No. So there are a lot of dependencies. So as of now, we know some basics in EC2 that will be helping me to create a simple EC2 server. Now the time to get on to the Linux operating system level to discuss a few more concepts. Once we are get familiarity with the Linux, then again we will be coming back to the EC2. We'll start continue our discussion in our AWS to deliver a few more EC2 resources. That is how the dependencies are there. We will be walking through with that specific sequence only, guys. Right? So I think that is good enough, right? And whatever the sessions that I'm delivering here, you can find all these sessions, right, in our documentation portal, edwiki.com, which is our educational wiki, right? You can always navigate to the tutorial section and can go to the AWS Linux Foundation learning notes. This is where you can see all the sessions that we are conducting here. Yes, this is now up to date, and I'm going to add all those sessions that we are going to talk from today onwards, right? In the same list, we can navigate to this to learn all these different concepts from the reading perspective, guys, right? As usual, so the videos are as well. The videos are actually uploading to the YouTube portal. You can go to this YouTube tab to navigate to our channel to subscribe and start looking into these videos for now. Going forward, all these sessions I'm uploading it into the courses tab as well, but at the moment this is not available for you, right? So I'm just helping for the people who are new to this, where you can find the learning notes and the recorded video material of this course. Thank you. Right, I hope this is good now, right? So considering that, let's jump on to the Linux today. Then after a few sessions of Linux, we will be coming back to the EC2 again. We'll continue the remaining resources in the EC2. Good. Being said that, now As I am using AWS as a cloud infrastructure provider to create a EC2 instances, right? So in my AWS management console, I have selected a region in which region I need a server to be created. Then let me click on launch instances. There are few things that I'm keep on repeating from all the sessions, at least initial days, because every day I need to create one simple EC2 server. There are a few things that I need to keep on repeating. I hope that helps you guys as well to recollect the concepts, right? Uh, when I'm creating a EC2 instance, I just need to give a tag, the name tag. You can give any additional tags as well as we discussed. Let me select the AMI, which is the operating system selection. I'm going with the Amazon Linux AMI. T2.micro as the instance type, which is part of your free tier eligibility. And let me use the existing key pair, which was already created, and the key was already downloaded it into my local machine already. It's very important that you do not touch the networking settings at this time, right? So we will talk about these networking settings at later time once we back to the EC2 after we complete our Linux basics, right? So with these default settings, let me go and launch a EC2 instance, right? So I got a instance ID created for me, and by this time we all familiar that the instance state may be a pending. After some time, the instance will be turned into a running state, and we can change the instance state as per the requirement anyway, right? So let me refresh. I just need to wait until the server turn into a running state and take this public IP. And of course, we know that the elastic IP can be associated to get a permanent static IP. But during the learning time, you don't need to worry about the elastic IP, right? You can take this default dynamic public IP, right, and can logging into this server. I'm using PuTTY, so let me specify the IP address there. Let me specify the key that was downloaded at the time of me created a key pair, right? You can always give the window preferences here by going to appearance, change. The font should be a bold and can specify the size, right? The attaching the key and specifying the font style, all these things, you don't need to do each and every time. The details that you configured here can be added as a session here. Let's say this is the CLF01 server. Any name would be fine. I'm just giving one name here, right? So that when I click on save here, right, this particular name is saved. Tomorrow, when you are trying to logging in to the EC2 instances using the same key, you don't need to attach the key every time, guys. You can just use this saved session, click on load so that the details will be automatically picked up. You can just click on open. That way it will use that existing key that was attached, then the login prompt will be appeared. As we know, the default username is EC2-user if you are using Amazon Linux AMIs and you just logged into the server using this username. Once you log in, you will be getting this kind of a prompt symbol. That is where you need to get started with your Linux operating system to run any commands to configure this for your business needs. I know you are having a question that what is that we need to do with this Linux machine. Our goal is we need to use this Linux system to host a website, and I wanted to serve a website to the users whoever wanted to access my services. By the end of our course, we will be there in the stage where we can host a website and can run a website from this EC2 instance case. And we are starting with the basics of Linux today to understand the various commands that we should be familiar with to go to the level where we can host a websites and serving the websites to the users, right? So whatever you see here as a prompt symbol, right, do not worry about this. Let it be the default for now. We will talk about all those dependencies as and when we go in detail about the Linux operating system behavior concepts. Good. Now, the next goal is how this operating system is working, and we need to understand the Linux operating system architecture, right? Let's get into that discussion now. So let's start understanding the Linux architecture in the sense how these Linux systems are working, right? How will you start make use of these Linux systems, correct? As I said, the Linux server, right, is just a integrity of the multiple hardware devices, right? Let's say the processor, hard drive, the memory, or any other interconnected hardware devices together will make a system, right? In order to start using this system or a server, right, we need to install a operating system on top of this bare metal hardware, right? Or else you can't use this. So let's say here I am choosing the Linux operating system to be installed on this machine. Then this is now called as a Linux server, which is your EC2 server. Good. So what is the Linux operating system? Linux is the software that can run, that can install and run on the hardware devices, which is giving you a interface for you to start interacting with the operating system to run your instructions commands to make this configurable for your business. That is the statement that I'm giving from the day one. So when the Linux is a software that can be installed on the bare metal system, right? The Linux is the mix of multiple software pieces in a sense. When the people are designing or developing this Linux operating system, right, the developers will be developing this OS as like a multiple pieces of softwares. I mean to say, this Linux is not a just one single software. There are multiple softwares will be developed for different use cases, and collectively together all those softwares will be put together to make it as a one single bigger software, which is called as a OS. That means when you install a Linux operating system, or when you are accessing the Linux operating system, the Linux OS is having one main important software in it is called as a kernel. Here I'm giving the introduction about what is it mean by a terminology called kernel. Kernel is the main important software that is available within your Linux operating system. The kernel software that comes along with your Linux OS is a primary responsible in talking to the hardware devices and making your things implemented. I'll give you one concrete example here. When you have a system with you, let's say you wanted to store one file in your hard drive. I can't go and talk to the hard drive, hey, please save my file, right? So there is a proper way of you communicating with your hardware. The hardware devices will be understanding only the binary kind of a languages, and whereas we don't know the binary language, we always speak the English or whatever the language that you know, right? So that's the reason we can't go and talk to the hardware devices directly in order to make your work done, correct? That is where the kernel is the software that is available within your Linux operating system. That software is capable to go and talk to the hardware devices and make your work done. So can I use this statement now? Whenever you wanted to work with your Linux systems, Linux hardware devices, you always need to give the instructions to the kernel the kernel will go and talk to the hardware, and finally your work will be done. That is how the flow will be there when you are making a instruction to your system. Again, when I say the kernel is the software that is playing the role in your Linux machines, which is going and talking with the hardware devices. It could be a processor, memory, or a hard drive, or whatever it is, right? Even the kernel is developed to understand a specific languages, a machinery languages. I can't go and talk to the kernel software directly. That is the reason on top of the kernel software, there is a one more software available, which is available as part of your Linux operating system, which is called as a shell. If you ask me what is shell, shell is also a piece of software that is available as part of your Linux operating system. The shell software is responsible, which is translating the communication that you are doing with your kernel. There are multiple shell softwares are available within your Linux operating system. All these shell softwares are actually responsible in taking the request from the user and translating that request to the kernel in an understandable language perspective. In a way, let's say you are a user and you wanted to do something on your Linux machines, right? The flow will be like this. You always give the instruction to the shell. The shell will understand what you are saying. The shell will be translating the communication to the kernel in the kernel understandable format. Then the kernel will understand what needs to be done. Then the kernel will go and talk to the hardware devices, and finally your task will be get implemented. Are we good? When the user is initiating a request, the request could be anything as per your business need. That request is always be giving to the shell. The shell is translating, interpreting that request to the kernel. The kernel will go and talk to the hardware devices, and finally your work is done. So in the sense, can I say that the kernel is the core component, a core software that is available within your Linux machine, which is a, a major role that is contributed to make your system is up and running, correct? Let's say for some reason, if your kernel software is not working as expected, do you think your Linux system will be operated? Can you talk to your Linux system to make your work done? No. Why? Any instruction that you are passing that is somehow translating to the kernel via the shell, and the kernel has to make this implemented. And if the kernel is not working, the entire system will be in a down stage. It will not be working at all. Now, when you have a EC2 instance with a Linux operating system, the the beauty in cloud is you don't need to install the operating system. The EC2 instances are come with a pre-installed operating system in it based on the AMI that you have chosen. All what you need to learn here is how to use the Linux operating system in order to configure it for your businesses, correct? Well, any Linux operating system can have only one active kernel at a time. You cannot have multiple kernel softwares active at the same time on your Linux machines, guys. Just to repeat, one Linux system can have only one active kernel at any given point of the time. But a Linux system may have multiple shell softwares can be in active mode at any given point of the time. You see here my diagram says there are multiple shell softwares that are available for you to translate the user language to the kernel understandable format. Yes, the multiple shell softwares can be made available in one single Linux machine, not an issue. In general, let's say, what is shell? The shell is the interpreter or a translator, right? Think of like if there are two parties wanted to communicate each other, if these two parties are not having a common language, then I need one interpreter in between who can be translating the one one guy language to the other guy, right? And if there are multiple users who would like to use my system and all these users are talking different languages, as an example, you see around my shell there are multiple users are surrounding. Let's say all these users would like to use my Linux system. All these users are using my Linux system for various business reasons. One user maybe wanted to use your Linux system to host a website. The other user may be using it for developing some different software. The other user would like to use your system for maybe making a scanning or a printing or whatever the businesses that they wanted to. Possible, right? A server or a system is supported to right run any type of the business that you wanted to. Based on the business nature that you have, your language may be differ, your use case may be differ, and obviously you need a corresponding shell who can understand and translate it into the kernel. Hence the reason you have multiple shells here. Each shell is capable enough to understand certain set of instructions and passing it into the kernel in a understandable language by interpreting it. Now, shell is the common terminology that I'm using here, right? So if I want to give the name of the shell, you see this basic search in the Google, right? In the Linux systems, right? There is something called Bourne shell, C shell, Corn shell, Jet shell, and you can see, there are few more as well, right? Born again shell, right? That means what? There are multiple shells are available in the Linux system. As I said some time back, each shell is having its own naming. So each shell is capable to understand certain set of instructions and that can be translated it into the kernel in an understandable format, guys. Based on your business case, based on your requirement, what type of instructions that you have, those instructions can be understandable by which shell. That is the shell that you need to use and asking the shell to translate your language it into the kernel understandable format. Is it clear? But we are trying to understand the Linux architecture here, how it is actually working. And should I be using all these shells to start working with my Linux system? Maybe I'm just going through one of the documentation here. This is where it is explaining the different shells that are available, including the the Bourne shell and the GNU, C shell, Corn shell, all these. Well, you don't need to worry in understanding all these shells. In a generic language, I am saying that these shells are there for you to provide a different business requirements to understand different instructions to pass it to the kernel. Now, based on my business requirement, what type of instructions that I wanted to, which shell will be more suitable, which can understand my language to translate to the kernel, that is what I need to pick up and start learning. That is mean that the bash shell, you see this born again shell, in a shortcut we can call this as a bash. Bash shell is the shell that is frequently used, which is most preferable shell, which is the default shell in the Linux systems that you need to use for your regular use cases, that where you are configuring your Linux systems. That means throughout our course, even in a working environment, you are only using the bash shell to run your instructions and configure your system for your business needs. We are not using any of the other shells that I am talking about here. The other shells may be needed for a different developers, may be needed for different business needs. But for our need, for our job responsibility, for our specifications, only the bash shell is required, and that is the default shell that is available in your Linux systems. So you don't need to worry how other shells are working, how to talk to these shells to translate your instructions, guys, right? So for our use cases, we need to only worry about the bash shell, and we need to learn how the bash shell is working, what type of commands that the bash shell can understand, and how the bash shell is talking to the kernel. That is what is our focus. If you're still asking me more, when I talk about the different use cases, the systems or servers can be used for research purpose, can you use for your website purpose. The servers can use for maybe a mathematical calculations, maybe used for C languages. I mean to say there are different reasons why a server can be configurable, right? So, and based on the use case, the kind of instructions that you pass on may be a different, so other shells are designed to deal with that kind of a scenarios. So we don't need to worry too much about the other shells, what kind of the instructions that can be understandable, right? Hence we are focusing on only the bash shell for you. Now whenever you logging into your Linux system, by default you are able to see this type of a symbol, right? Whatever you see, this a dollar and the some text here, whatever you see, this is called as a shell prompt symbol. That means when you logging into the Linux operating system, you are granted with a bash shell. So whatever you see in the screen, whatever the dollar prompt that you see here, this is called as a bash shell prompt symbol. If you get this bash shell prompt symbol, is mean that the bash shell is granted for you. Now this cursor is mean that this is ready for you to run a instruction or a command. In simply put, whenever you logging into any Linux machine, if the bash shell is granted for you, then you will get a cursor and you will get a shell prompt symbol. Is mean that the bash shell is ready to accept your instruction to translate those instructions into your kernel. All what you need to do is now start running the commands here, which commands that the bash shell can understand, right? And make this configurable to your business needs. Now the bash shell can understand what type of command, that is what we are focusing, right? So we need to learn some Linux commands that we can run here, which can be understandable by the bash shell. If you run anything that you like it, for example, you see the bash shell is complaining. You see the error? The error is clearly stating that, right? Whatever you have executed here, that is not found. Who is complaining this error? The bash shell is complaining. I'm just proving that the bash shell is available to you to accept your commands and can try to translate them it into the kernel backend. Whenever you are running some command which is not understandable by the bash will complain that, hey, I don't know this command and I cannot translate it into the kernel. Makes sense, right? Usually if there is an interpreter in between the two persons, the interpreter should understand the both languages. Then only one person, whatever he is speaking, can translate it into the other party, right? So here, what the bash can understand, that what we need to learn, and we need to give the instructions to the bash as per this. Make sense? Now, let's see what the bash can understand, right? And then I will be executing only those instructions here to make this configurable. Second thing, like a Windows operating system, the Linux is not available as a graphical user interface. This is a completely a command line interface operating system. Any instruction that you wanted to give, that can be given only by executing a commands. Each command has its own meaning. purpose, right? We need to understand what command will give what kind of results, then you execute it as per the need. You cannot do a mouse over, can do a right click and do no configuration the way how you do it in your Windows platforms. There are the Windows, sorry, there are some Linux operating systems that will be providing you the graphical user interface where you can work through the mouse, but that graphical user interface Linux operating systems are applicable only to your home based laptops only. When it comes to the business side, then you are not getting any kind of a GUI. You are only getting the command line interface operating system. You should learn the commands to talk to the Linux machines and execute them. With this discussion, I'm setting a mindset for you guys that you need to start learning the commands to run these things in the Linux machine. Those commands will be taken by the bash shell. The bash shell will start uh, translating them to the kernel. The kernel will make this implemented in the backend. That is how the Linux architecture will be working. Now the next thing is, what kind of activities that we need to do on the Linux system, guys? What is that we need to do on the Linux system? I think you are all familiar with the Windows machines, right? I think no one need to teach how to use the how to use the Windows machines. Usually, if you are using the Windows systems, you know that the Windows system is having a C colon, D colon, E colon. You know that those are the different drive partitions that are available. You know that these drive partitions are just a flexibility for you to store your data. Whenever you wanted to keep any data in the Windows systems, you usually go to that drive and then you follow the folder path. You go to the selected folder. Inside the folder, either you create a subfolder or you create any file in it. That is how you are actually maintaining a data model on your Windows systems, right? Can you talk about few tasks that you are going to do in a Windows system, guys? It could be storing a file or creating a file, creating a folder, moving the folder, moving the file, delete a file, delete a folder, correct? Maybe the copy the file, copy the folder, maybe you delete the entire folder hierarchy if it is having subfolders. So isn't it? These are the different activities that you do on the Windows systems, right? And you are very much familiar how to do that by using the mouse click. We can easily navigate from one folder to another folder, all these things. Why do I use the folder here? Just to make your data in a flexible, correct? I don't want to keep all my files in one single folder and causing it into the confusion to manage the data, right? Just for organizing your data in a proper fashion, stating maybe your movie files should be in one folder, your music files will be in another folder, your documents will be in another folder. That is how we are organizing your data in a multiple folder structure to manage them easily, correct? Yes. Same thing. Now we are going to achieve it a Linux machine. No difference. The Windows is giving you the UI flexibility where you can use the mouse click. No one need to teach the Windows, right? You can easily navigate and search yourself, explore yourself how to make use of the Windows operating system to store your data. Initially, yes, I am comparing with the Windows because you are all familiar with that systems. So that way, it's very easy for us to understand the Linux as well. At least you will not think that the Linux is something new, at least when I compare it with the Windows systems. Can I use this statement? Whatever the activity that you do with your operating systems, could be a Windows or any other, ultimately you are trying to do two things. One, You store the data. Second, you retrieve the data whenever you want the data back, correct? Now you think of, guys, what kind of activities that you are doing in your Windows systems. Definitely, you are storing the data, you are retrieving the data whenever you need it. These are the two things that you are doing. The storing the data could be any format that you like it. Retrieving the data could be for any reason. It could be reading a file, could be playing a movie file, could be any other. All are treated as like a retrieving the data only, right? Yes. Now we need to understand how to do all these things in the Linux system. The files and the folders that you are managing in your Windows systems are organized properly. One folder has a subfolder, Same way, the files and folders are organized in the Linux system as well in a proper structure. We need to understand it. The way how the C:colon is the starting point in your Windows system to get your files and the subfiles. Can I see anything above the C:colon, guys, in the Windows systems? No, right? C:colon is the starting point to access your hard drive, and anything should be under the C:colon only, correct? The same way, when it comes to the Linux machines, slash is called as a root level folder. Under the slash root level folder, all other subfolders will be get created. From the terminology perspective, the folder is called as a directory in the Linux systems. Folder and the directory both are same. Folder is the Windows terminology. The directory is the Linux terminology. The both are same. Like the folder can contain a subfolder or a file in it, right? Yes. The directory can contain a subdirectory or a file in it. That's only the thing. The terminology changes, but folder directory is same. So slash is nothing but a root folder or root directory. In the root directory, you may be seeing some subdirectories like opt, home, tmp, and these are the standard directory names that you can see in any of the Linux machines. On these standard directories, then you can see some subdirectories as well. You see here, each directory is having some subdirectory. The subdirectory is again having some more subdirectories. That is how the directory structure is maintained in the Linux systems. It may be very much new for you what is OPT, what is TMP, all these things. But when you go to the Windows systems, right? Ideally, you see a Windows program files, users, downloads, my documents, my pictures. Yes or no, guys? You used to see those folders, the default folders that exist in any Windows system, right? Why? Those default folders to keep certain important operating system related data in it, correct? Ideally, the Windows says that, hey, the downloads folder to keep all the downloads that you are doing. My documents is the default location to keep all of your documents. Like that, every folder has its own meaning and the purpose why those default folders are there in the Windows system, right? Same way, in the Linux too, there are some default directories that are created. Each directory has its own meaning, purpose, and what type of data that you need to keep in these folders is fixed. Of course, down the line we will definitely see the the purpose of each and every directory that is there here. Don't need to worry about this now. Yes, but the opt, home, tmp, usr, etc, so on so on, right? These are the standard directory names that will be exist in all the Linux systems. Each and every directory has its own meaning, purpose. We will be definitely learning through that model. As of now, every directory has its own subdirectories, and those subdirectories may have some more subdirectories, and the files can be created as well. That's how the file and the directory structure will be created in the Linux systems. Hope this is good. Well, then how to get start with, right? How to get start with this Linux system? What are the different commands that we need to understand here, right? Let's get into that practical. Now, in order to work through, right, we need to run some commands in the Linux system. Those commands will be taken care by the bash shell, right? Let me start introducing you a few commands. The first command is ls. Any command that you type when you see the cursor in your bash prompt symbol, and you after you type the command, you just hit enter so that the command will be get executed. ls is the command to see the list of files and the directories that you wanted to. If the ls command is not showing any output, then it means that wherever you are currently working on, there are no files, no directories that are available to you. So it's a empty one. Now, who am I, right? Who am I is the command which will be telling you that who currently logged into this server. You see, EC2-user is the command, sorry, is the user that have used to logging into this system, right? And you can see that as an output. So ideally, you run a command, the command will give you a output. That output will be displayed. After the output, again you see a cursor with the bash prompt symbol. Why? You can run the command only when you see a bash prompt symbol. Without a bash prompt symbol, you cannot run the commands. That's the reason you execute one command, the command is giving you a output. After the output, again your bash prompt is waiting for you to run any more commands as well. Ideally, if it is the Windows, if you wanted to know who currently logged into your Windows, you go to this start button, right? You may be going to here, maybe you look into your user details, something like that, right? You see this is the user who currently logged in at this time. The same thing I'm trying to achieve using the command line in a Windows system, sorry, in a Linux systems. Who am I is the command to let you know who currently logged into this Linux server. Date is the command which will tell you what is the current date that is configured in your Linux server. Like how you see the date in your Windows, you do a mouse over to the top, sorry, to the bottom right side corner, you see this calendar, right? Correct. The same thing now can be seen in the Linux systems by running the date command, which will be showing you along with the time zone. Like the different time zones are there based on the locality, right? Currently, the EC2 instances are by default configuring with the UTC time zone, which is the universal time. Good. Cal is the command to see the complete calendar of the current month, guys. You see, currently it is showing the current month calendar, and the today date is actually highlighted here. That is how you see the calendar in the Linux systems. As and when you keep on running some commands, you see that each command is giving you the output, and your bash prompt symbol is keep on going to the down. Let's say if I run the cal command one more time, you see that the bash prompt symbol is came to the bottom of your screen. Will you be flexible in running the commands when the bash prompt is at bottom lines or the bash prompt is at a top line. Usually you will be flexible to run the commands when your bash prompt symbol is at a top right, not at a bottom. Yes, we can always use a command called clear. The clear command will actually clearing your screen and taking this bash prompt symbol to the top line. The clear command is not actually clearing all these things. Only the screen will be cleared and your bash prompts will come into the top line. Usually, if you do a little scroll, you see all the previously executed commands, the history is there, right? Only thing is the clear command will just clear the screen and taking your bash prompt symbol at a top line, so you are flexible enough to run any more commands when your prompt symbol is at a top lines. Now uptime, uptime. Uptime is the command that will tell you that this Linux system is started when. You see, it's stating that up 39 minutes is mean that this system is actually started 39 minutes ago. That means when you launch a EC2 server, that is the time the server is started it into the running state, right? So it's been a 39 minutes now when the system is started. It will just help you that since how long your system is in the running state, all those things can be seen from this uptime command. Any command that you run, you will be getting the output. You need to understand the output, what it is telling you. But during the learning time, you don't worry about learning all the things that you see in the output. It takes some time because certain things has some dependencies, right? Let's say the load average. In order to understand what is it mean by this load average, it takes a few more classes. So I will be not covering all the things that you see in the output at a same time. I'll be keep on going back and forth, and when the time comes, I'll be explaining the different other options, right? Later part of the time. The commands, whatever I'm executing here, all are running in your PuTTY terminal, right? When I logging into the Linux machines using my PuTTY software, the PuTTY has given you this type of a terminal. You see, in my Windows, right? In my Windows laptop, I got this PuTTY terminal, right? In this terminal, I got this shell prompt symbol of my Linux server, and I'm running all these commands. Technically, what is happening, guys? These commands are executed in my laptop. No, right? So all these commands are executed in the EC2 server. The server is located in the Mumbai region of data center, right? Whatever you are running here, those commands are transferred, sending to the server. The commands are being executed by the processor and the memory that is available in the Mumbai data centers. That's where my server is currently running. I'm a remote user. I logged into the server using the PuTTY as a client software, and this terminal is helping me to get a bash prompt symbol to specify my instruction. The instructions are being executed by the server that is running in the Mumbai data center at this time because I have chosen the Mumbai as the region when I'm creating a EC2 instance. Make sense? The way how you create a folder under the files in the Windows systems, even in the Linux system, you can create a folder by running the command called mkdir. Because from the Linux terminology perspective, the folder is called as a directory, right? So mkdir is mean that make a directory. So when you are creating a directory, you need to specify the directory name as well. If it is Windows, you usually go to the right click and create a folder, go to new and create a folder, and then you will be specifying the folder name, right? You see, this is how you create a folder. Once the folder is created, then it is asking you, hey, what is the name of the folder that you wanted to give it, right? When it comes to the Linux, mkdir and space, you specify the name of the folder that you wanted to give. You see, now the folder is created. The folder name is movies. Mkdir data. The data is the name of the directory that I created. Mkdir dir1. dir1 is the name of the directory that I created. That's how we need to create a directory. You see that in the Linux, some commands are one word and some commands are actually taking two words. Whatever you use the first one, that is called as a command, and after that whatever you pass on, that is called as a argument. Some commands may need a arguments, some commands it don't need any arguments. It all depends based on the type of the command that you are executing, guys. So in simple words, in the Linux, the commands can be executed alone, or sometimes the command may expect a argument as well. Let's say mkdir, if you run without passing the argument, you will be getting a error because your bash terminal is trying to understand the command to translate it into the kernel. The bash is not able to understand because you have not given a proper syntax here. The mkdir always require a argument and you are missing that, right? That's how you get an error if you are not executing the command in a proper understandable format by your bash. Good. The way how you create a directory, if you wanted to delete a directory, let's say I don't want a directory to be, so rmdir is the command to delete a directory and specify the directory name that you wanted to delete. That's it. You see, rmdir, rmdir. This is how you need to delete a directory. And of course, you need to specify the directory that was already created to delete it. These directories are already created some time back. Now I have deleted them using the rmdir command. Touch is the command to create a file. Usually in the Windows systems, you do a right click and create a file. This is how you create a simple text document, right? Which is a file. The same thing can be done in the Linux systems using a touch command. Touch, then you specify the file name, whatever the file that you need it. We have seen a command called ls, right? The ls is the command which will be showing you the list of the files or the directories. You see now, the ls is showing that currently you have a file called f1.txt. You have a directory called movies. The remaining all I deleted. You see, data, dir1, dir2, I created and I deleted already. So those are not showing in my list. Let's say I will do mkdir dir1. Now if I see the list, you see the dir1 also showing in the list here, right? If it is Windows, you usually go and just try to do a double click on the folder that will start showing the list of files and folders in it. But in the Linux, the same thing can be seen by running the ls command. Good. Now, the folder and the file has a difference, right? What's the difference, guys? The folder can contain a subfolder or a file, whereas the file can contain a data, correct? Some text data can be put inside a file. Can I keep a folder inside a file? No, that is technically wrong. So definitely when you are looking into the list like this, when you see this list, you should understand, right? Which is a folder, which is a file. How will you be understanding which is folder, which is file? Maybe if it is a Windows, you understand it by looking into the representation, correct? The folder has a different representation, the file has a different representation. If you're still in confusion to understand which is file and which is a directory, you always looking into more details, right? This is where at least you will know that the entity is a folder or a file. This is a confirmation which is also giving you more details about what is the size when the file or folder is modified, something like that. The same kind of details I'm looking in my Linux machines as well. How? The ls is by default showing you only the list. If you are on a confusion out of these three, which is folder, which is a file, you can always run a ls command with -l as a flag. Same thing. In Windows, how you get this view by details, the same thing I'm getting it in the Linux machines by running the ls-l. That's it. You see now the dir1, right, is having more details here. Any entry is having one liner. The starting character will tell you whether this is a file or a directory. You see, when it starts with a D is mean that that is a directory. When it starts with a hyphen, that means that is a file. That is the notation for us in the Linux systems to understand whether that is a file or directory. Is it clear? We can't understand by looking into the name or a color, guys. We always need to depend on this starting element. D refers directory, hyphen refers a file. The directory can contain subdirectories, whereas the file can contain only the text data that you need to keep on. Good. The details that you see about all these things, let's say the D, and you see a lot of details, right? Yes, definitely we are going to learn all this. What does it mean by this information, right? But can I say the information that you see here are called as a metadata about your directory or a file? Yes. Metadata is the terminology that I'm introducing here. Metadata meaning is the data about your specific element. In the sense, the dir1 data is represented here. This data is telling whether this is a directory or a file, is telling when this directory is recently modified or created, and is telling the size of the directory or a file. So like that, it is telling more details about your file or a directory, right, which is called as a metadata. Good to see all this, but what is this hyphen l, right? Hyphen l is nothing but a flag in the Linux. Any flag will start with a hyphen. After the hyphen, you need to specify one digit or one character that is called as a flag. What the flag will do? You see the command is same. Sometime back I have executed ls. Now I'm executing the same ls command, but when you give the different flag, you are getting the different output. is mean that the flags are changing the behavior of the command, how it has to operate and how it has to give you the output producible. That behavior changes will be happening based on the flag that you use for your command. I mean to say the ls is giving you the list, ls-l also giving you the list, but the kind of the details that you see are different, right? So when you give a flag to the Linux command, your Linux command behavior will be changing in terms of the way how it can produce you a output. Can I say the flags are optional? Yes. So sometimes you may need to pass the flag, sometimes you don't need to. So the flags are optional. At a overall, a Linux command will be like this, right? A command, then you need to see a flag, then you need to see an argument. This is how a typical Linux command will be formatted. In this, the command is mandatory anytime. The flags and arguments are optional. Whenever you see you wanted to give, you need to give, and you need to understand at which scenario you need to give the flag, at which scenario you need to give the argument to that command based on what is that you are expecting it from the Linux machine to configure it. I'm just showing the Linux command format here, nothing new. Are we good with this? In order to remove the file, the command is rm. rm, specify the file name that you created some time back and hit enter so that your file is now deleted. You see, the f1.txt is not available here. That file is deleted. Now, let me clear the screen. The way how a Windows system is having multiple folders and how you navigate to these folders, you see, usually when you're logging into the Windows system, you will be landing into your home into the desktop. Then you will be keep on going there and here, right? By navigating it into the different folders. You see, this is how you are navigating to different folders because you are keeping the data into different folder hierarchy, right? That's how you go to there and here. Same way. Even the Linux systems are having the multiple directories and the subdirectories, right? I'm curious now to see where I am currently working on. Just to give you more context here, let's say in my Windows I'm here. Where I'm currently, guys? So can I say this? Currently I'm in F colon web app. This is my current working location. Is that the true statement? Right? Currently I'm working in this particular folder, and from here I can navigate to any other location that I wanted to. You see, from this present working directory, from this working folder, I'm going to the downloads folder. You see, this is my location, and from there I can go to the my pictures and can go to any other location that I wanted to. That means, yes, when you are working with your system, you always should know that you are currently working in which location. pwd is the command which will tell you your present working location. Whatever you get a output of this command, that is your present working location, guys. That means EC2-user is the folder name. That folder is inside the home folder. The home folder is inside the slash folder. That is how the directory path is represented in the Linux systems. Same thing, no confusion. When it go to the Windows systems, the way how your path is represented here, this is how it is, right? You see, where you are currently, you are in the F drive and one folder, and inside there is a one more folder. The same thing is represented here as well. The starting slash is the starting directory. Inside that there is one more directory. Inside that there is a one more directory. That is how the path is represented. The starting slash is called as a root directory. After that, whatever the slash that you see, that is just a separator to separate the two directories. Like in Windows, how you see this backslash, that is the separator to separate a folders, right? So the same way in the Linux systems, this forward slash is used to separate this structure. That means where I'm currently, guys, as per this, there is a top level root directory. In that there is a home directory. In that there is a one more directory. The directory name itself is EC2-user, and this is the place where I'm currently in, and I'm working in my Linux system. Yes, there are few other directories as well in the system. Yes, if you want, you can go to any other directory that where you wanted to from this current working location. Are we good with this? Let's say for any reason you don't want to work on the present working directory, you can always use the cd command to switch to any other directory that you would like to go. Let's say I wanted to go to the directory called tmp. This tmp directory is inside the slash, right? As per this architecture, what I can do, cd, I wanted to go to tmp directory. The tmp directory is inside the slash. You need to execute the command like this. Now you see, currently I'm working in slash tmp location. The way how in Windows you do a double click and navigate to these folders, the same way in Linux machines, cd command and specify the target to where you want it to go. That's it. Now your present working location is changing. Because this is not a graphical user interface, there will be a lot of confusion initially for the beginners comparing to the Windows, which is giving you kind of super navigation structure, right? But overall, they're doing the same. Again, if I wanted to go back to some other place, you see, under the slash, I wanted to home. Under the home, I wanted to go to this location. You see, again, I went back to my previous location by using the cd command and specifying the path, right, where I wanted to go. Good. Now, when you have multiple directories in your Linux machines and you can work on any directory, right, as per your wish. Can I say this? When a user logged into the Linux machine the very first time, when you get a bash prompt symbol for you to run a command, definitely a user should be landed it into any one of these directories, right? By default. Correct now? Though you have thousands of folders in your Windows machine, but the moment when you log in, what is your default landing place? Desktop, right? The desktop is the landing place. Then you can go to any place that you wanted to. Same way, the default directory where you will be landing when you logging into the system, that directory is called as a home directory. From the terminology perspective, home directory is the default landing directory for a user when he logged into the system. From the home directory, wherever you wanted to go can easily go by using the cd command. You see, cd slash, you see, I went to the slash directory, which is the root level directory. I cannot go above the slash. Anything will get start with a slash only, right? Now you see, when you run a ls command under the slash, you see all these are the different folders are there. That I have already shown you that under the slash opt, usr, var, tmp, right? All these are there. You can get more details like this. L flag, you see, all these are the different folders or directories that are exist under the slash directory. These are the default standard names that will be available in any Linux system, as I have shown you in the presentation also. Whichever the location you wanted to go can easily go by running cd under the slash. Let's say I wanted to go to the directory called usr. Go there. That's how we need to start navigating, guys. Make sense? So these are just a basics to understand the Linux architecture, how to get familiarity with the bash shell and running the few minimal commands. Going forward, we will be keeping more eye on these commands, the directory structure, how to get familiarity with the directories and the files, and we'll see some lot of scenarios around it. I think for today, this is good enough. We are just understood the Linux architecture and the terminologies like kernel, shell, bash shell, right? And the directory, home directory, and we talked about some Linux commands, right? That we can execute in the Linux systems. Any questions? Do let me know, or else we are good for today. We'll regroup tomorrow. We'll continue our discussion. We will get more familiarity with the Linux systems to configure this to run our website. That is our goal. Answering to the question that what is a use case? I'm sure we are having a mindset that why we are doing all these things. What is the use of all doing all this, right? I agree. We need to wait at least another 2-3 days of time to understand why we are doing all these things. Then we'll come to a situation to understand the use case and how these are helping our to run our business. I would like to say something like this. Usually, when a kid is learning ABCD, they really do not know how the ABCD will be helping in their real future. They have to learn ABCD as it is. Maybe after a few days of time, then they will understand those will be constructed into a wording, then to a sentences, then a language. Then they will know the actual real use case, how that will be beneficial for him, right? Assume the same way. We are in the beginning, a basic section. These basics I'm going to apply in later sessions to make use of them to construct a use case and run a actual business. I mean to say the business use case where I wanted to run a web application here and use this in your web browsers. Hope this is fine, right? Thank you very much for your time today. We'll regroup in next session. We'll continue our focus and we'll get familiarity with the Linux. Thank you.